So we're going to speak about delete square brackets. I'm teaching C++, and I'm occasionally being asked, why should we use the square brackets? And then the question is, and if we forget? And I just say, do not. But then the question is, OK, but actually, why do we need these square brackets? And yeah, it worked for me.
It works now?
Yeah.
OK.
I think. Otherwise, maybe you pressed that?
Yeah, I pressed it.
Oh, now it works.
It works on the other direction.
Oh, yeah.
Oh, OK.
So a disclaimer. All information provided is compiler-specific, non-applicable, and should not be used in real code. It's theoretical only. So why delete square brackets? Because the compiler in C++ doesn't distinguish between a pointer to a single object and a pointer to allocation of an array. We all know that. And we were told that delete PTR calls the destructor of the object pointed by PTR and then also releases the memory pointed by PTR back to the heap. Now, if it is an array, then we need to call more than a single destructor. So there is a need to achieve somehow the number of objects pointed by PTR, call the destructor n times, and then release the underlying memory. And in order to avoid the need to calculate the number of objects on the allocation, if it is a single object, we don't want to call it with square brackets, right? So let's play with it a bit. How many destructors shall be called in this case? 10, I would say. And what about this one? It's simple, 1, right? And what about that one? It's a morning. I'm starting, slowly. That's 1 as well. And what about that one? Is it legit? Yes, it is. What is the size pointed by the PTR? I mean, we can use malloc usable size and ask what is the allocation, the actual allocation being made. And the allocation being made is of size? Size 1. In this case, the size of A is 1. So is it related to the size of A? I'm not sure. I think it would be 1 anyhow. And then the question is, in this case, the actual object is 1. One object takes 1. 0 objects take 1. So how can the compiler know? I mean, generate the proper assembly to actually call the proper number of destructor calls. I mean, for 0, it should be 0, but the allocation was 1. Same as allocation for a single object, and the size of the object was 1. So the story is not exactly that. Wait, we didn't have a destructor in this case. And since we didn't have any destructor, then, there isn't any destructor, so there isn't anything to destruct. So the story is a bit more complicated when there is a destructor. So let's assume that we have a destructor. Let's assume that in this case, again, the destructor is non-virtual in this case. And now, if we ask for the malloc usable size, we get some bogus results. I mean, numbers which are not correct. OK, what's the issue? Let's add address sanitizer. Address sanitizers crashes us. OK, you cannot ask for malloc usable size in this case. So let's add a flag saying, ask an option, check malloc usable size 0, which means don't crash me on wrong calls or on calls to malloc usable size. That returns something that is not malloced. And now it works, but returns 0. So was the allocation 0? No, it was not. So the story is a bit more complicated because, again, a disclaimer, the compiler actually allocates the required number of objects, but it also allocates a size t just in front of the allocation, where it stores, it stashes the actual size. And then when we deallocate, it goes there and fetches the size. So if we are not trivially destructible, then we can go back ourselves to 8 bytes, let's say, or size t bytes before the allocation, and look for the actual number of elements being stored. And we get these numbers there in this location in memory. And if we actually ask for malloc usable size on that location, which is the actual location where we got the allocation, because the allocation was starting from this additional size t. So now we actually get the actual size. Here, the destructor is virtual. So since the destructor is virtual in this case, the size of A is 16, and you get the math for that. A disclaimer, this is non-applicable. Delete it. And now when your mind is fresh, I'm one of the organizers of Core C++. Core C++ 2024 is open for speakers. Call for speakers is open. Please submit the talk. Thank you very much.
Thank you.